The outline of the talk will be somewhat like this. We will have an overview of the solar system, which will consist of what are the materials, what are the things which we have in the solar system, interplanetary matter, how the planets are formed, and what are beyond planets, what are the other things which are available in the solar system. And then we will come to the Earth-Moon system, and then we will describe something about what is the Earth-Moon system, how tides are formed. So, as I was telling that, I will start with an overview of the solar system, and then we will go for the Earth-Moon system, and then we will see that we can classify. After going through the Earth-Moon system, we will come through two classes of planetary objects, planets actually. One is the terrestrial planets, and then we will go to the Jovian planets. We'll discuss each of them in fair details as far as time permits, and then we will finish off the session with discussing about the various moons, rings, Plutoids, and other things like Galilean satellites and all those things. So let us start. Why is the study of solar system so important? Solar system, because by studying the solar system, we only because not only the planets, the various materials which we will be seeing, various objects which are present there, the astronomers have given a lot of insight in how our solar system evolved, and from that actually we get information, because everything can't be, we understand our own planet, how it evolved, and not only that, other planets, planetary systems, how it evolved. So all this gives a rich source of information, and we need for a lot of different kinds of observations, because we need something which has not been tampered through the ages. So we have to search for objects which are actually preserving early formation periods, signatures of early formation periods, and people are studying asteroids, comets, meteors, and we will discuss briefly all these in fair details as we go on. So we start with an asteroid. This is a picture of the asteroid Itokawa. Now see, this is pictured by Japanese spacecraft Hayabusa, and it was launched, this spacecraft was launched in 2003, and it approached the asteroid, and you can see in 2005, and it soft landed, scooped material from inside, and it has returned the material by 2010 to the Earth. Now we are today capable of doing all these things and getting the material from asteroid which is going out, and it comes to the inner solar system, and it goes out, and most of them are less tampered by the heat and other things. So we got a lot of insight actually how all these things are, how the full things got evolved. So that is the reason actually we choose this particular thing. So a broad inventory of what are the things present in our solar system. Of course, we have the planets. The planets picture changed through ages. What our ancestors knew, what our in fact father or great grandfathers knew, also has changed through ages. Today, by planets actually we mean from Mercury to Neptune. These are the planets we consider. And then there are actually some objects which are between Mars and Jupiter. They are the asteroids, and beyond Neptune there are a Kuiper belt, and lot of objects are there, which we will also see which type of objects are there. And as a whole, this full structure, then the dust particles, these objects, these comets, these all gives us clues actually how the entire system started, how the entire system formed, and in fact how life ultimately evolved. And so much money has been paid. In fact, now also Perseverance is in the Mars, so we are searching out all the clues for getting the full puzzle together. So as you can see from here, our astronomically speaking, actually our solar system, though it is vast, though it is thin, but when you compare it with the distance of our nearby star, that is Alpha Centauri or Proxima Centauri, it is around 4.37 light years, and the diameter of the orbit of Neptune is only 1/3000th of a light year. So you can understand the scale in which actually we are trying to understand the full thing. So this is a picture of actually we have our solar systems objects. We have the Kuiper belt object, interstellar belts, interstellar object, and other things, Oort cloud, comets, all these things put together, we have a complete structure. There is one more slide in which actually we can see the different type of things. Now let us just focus on some of the parameters of our solar system objects. For example, we have said that there are planets. Now you see that when you see the orbital, semi-orbital axis, and the masses, the radius, in fact the density, and these are the parameters. And if you just see through the density of these objects, you see that the density of Mercury, Venus, Earth, say Moon, Mars, these follows up till Cirrus. This follows a particular range. For example, 2700 to 5400. In fact, if you just leave out Cirrus and Moon also, it is around 3900 to 5400 kilogram per meter cube. But then if you go through the other things, Jupiter, Saturn, Uranus, Neptune, Pluto, and so, you see that the density goes down. So these all things, actually all these are planets, but then we are seeing that there are two classes of things present, two classes of objects present. One is having a bigger density, maybe their evolution is something different, there may be causes for this, there are causes for this, not maybe, there are causes for this. And then we have also, we are seeing that we have the our other class of objects who have a lower density. And then there are of course other things, like you can see that in some cases the number of satellites initially are less, and ultimately we have lot of satellites, artificial satellites, means natural satellites coming inside. And mass is also in some cases, after this density decreases, mass gets increased. So lot of so these things give some clues actually in which direction we should classify the objects. So astronomers and scientists, what they did is that they classified the objects into two major classes. One they called as terrestrial objects, and another they call as Jovian objects. So what are terrestrial? Which are the objects which are terrestrial? Terrestrial objects are taken as Mercury, Venus, Earth and Mars. These are the planets which are taken, and these are, because of their density consideration mainly, they are grouped together because of their size, density and majorly density considerations. They are grouped together, and their structures are also, we will discuss, they also have a say on this classification. And we have the other class, that is Jovian class of our planets, that is Jupiter, Saturn, Uranus and Neptune. So you can see that if you broadly classify these two, actually we have terrestrial are closer to the sun, Jovian are farther from the sun, and the packed orbit, smaller mass of terrestrial, very large mass, larger mass of Jovians, radii smaller, larger mass, the density, high density for terrestrial, low density. Rotational period are relatively low for terrestrial, faster rotations we have for Jovians. Weak magnetic field is for terrestrial, strong magnetic field. No rings are found in terrestrial planets, whereas we have many rings in the Jovian. So we have a widely different two different class of things. And why should actually the same nebula, same process which generated the total solar system form the two class? That is a thing which actually we already have some answers for it, and people are also trying to find out by various studies the better answers to get and understand all these processes. If you compare the sizes, if you take sun, our star, the sun, and other planets, you can see that how vast. It is not numerically shown, but it is in scale diagram, it is fine. So you can see the Earth's comparison to our sun. So this gives a thing. And then we have other objects in our sky. For example, we have the asteroids, we have meteoroids, we have comets, dwarf planets, all these things. And some of the asteroids which we will be discussing are actually they are passing quite near to the Earth, our planet, so that people say that sometimes actually one of them has hit, and it hits fairly at a period of say 1 million years or so, and we have a devastating destructive thing which is happening to our planet. And this is not only common to our planet, actually these types of things, these types of catastrophic thing actually repeats itself in various things. That is the reason actually we see so many cratered objects. So asteroids, this is a general description of asteroids, how from which range to which range. For example, 2.1 to 3.3 astronomical unit. One astronomical unit is the average distance between Earth and Sun, which is 1.5 trillion kilometers. And so you see that the asteroid belt is located between Mars and Jupiter, that is 1.5 astronomical unit and 5.2 astronomical unit. But most of these, and one more thing which have to take care is that all these are rotating in prograde means except one, all these are rotating in prograde orbit, revolving in prograde orbit, and rotating also in most of the cases it is in the direct motion, that is towards the direction of the rotation of the sun, except Venus it rotates opposite direction. And we will see that Uranus, one more gas giant, it is side tipped. Now and then there are actually certain asteroids which share the orbits of Jupiter. These was studied. These few asteroids they are actually either constantly 60 degree ahead or 60 degree lagging behind the orbit of Jupiter. These are called actually Lagrangian points. After Lagrange, mathematician Lagrange has studied this particular thing. These are the stable points, and it will remain in that point as the full system moves. And we also see that the eccentricity also has a wide range, point 0.03 to 0.3, and there are about 9,000 Earth crossing asteroids, out of which around 1,500 are potentially hazardous. Say for example, they are 150 meter in diameter, and they orbit within 0.05 astronomical units, so they are moving quite near to us. So it sometimes becomes catastrophic, as I was explaining. So let us dwell a little into the asteroids. Asteroids are fantastic object. It was actually people, when they first discovered Sirius, they thought due to Bode's law, they thought that they have discovered a new planet. But then ultimately they found out again and again lot of new objects, and they found out that they can't classify that as a planet. So Sirius was actually dethroned from the class of planet, and then it became to Uranus. That we will come back to it. You can see that some other pictures of some other asteroids available here, like Gaspar. This was photographed by Galileo spacecraft from a distance of around 1,600 kilometers. We see another photograph of Ida, which was also photographed by Galileo space probe around 3,400 kilometers away, and Mythal D from the Near spacecraft. It was photographed in 1997 on its way to Eros. It was flyby process, means as it was flying by this particular thing, it has photographed. So it revealed actually that, and one of the interesting thing is that when they near photographed Mythal D, it actually got that there is a moon around this particular asteroid, and they call it as dactyl. It is around 1.5 kilometers. So an asteroid also has a moon. It is not only that a planet should have a moon. So these concepts, actually these new observations start giving new insight, and all these asteroids, if you take full together, actually it accounts for a very negligible amount of mass as compared to the mass of the solar system. Forget about the mass of the solar system. Mass of the moon itself, it takes 1/10 of the mass of the moon. So this is what I was telling about the asteroid Ida and its moon dactyl. Its density has been calculated because it's by dynamics. Its mass is found out by photographic methods. Its volume is calculated, then density can be calculated, and average estimate of density is coming to the 2,100 to 2,100 kg per meter cube, and it is a rocky surface like our Earth, and it's around 60 kilometers. So these all the things have been known, and this type of new information like a satellite also exists for. Then we have found out another asteroid called Vesta. It was found out by NASA's Dawn probe in July 2011, and its overall surface feature, you see that it has distinct craters. As you can see, these are some of the impact craters, but then you are seeing some horizontal line. So something might have happened here. So again, when we get high resolve pictures, we try to find out the history of these particular things, how actually it what made it appear in this particular way. And then for one more peculiar thing is that this particular Vesta, this asteroid, actually its northern hemisphere is only 1 to 2 billion years old. Means from calculation it is found out it is much younger than actually the southern. So here there is a typographic error, that should be southern actually. And then we have the south polar region has is the largest mountain, not one of the largest mountain in the solar system, of around 22 kilometer high. We will see that the largest mountain as far as planets are concerned, it is Olympus Mons in Mars. But again, this particular Vesta has the largest mountain in the solar system. And then we have Cirrus, it is reclassified. We have seen these pictures of Vesta. Then Cirrus was reclassified as a dwarf planet afterward. Dwarf planet was how the concept of dwarf planet came up, and how actually afterwards we have a new class of object called Plutoids. We will come back to it at the end. But then actually these, as I was saying, that UCP PRZ first got the asteroid in 1801, and then Dawn actually arrived in 2015, and it was first labeled as a dwarf planet. And then you can see that from the various data, it was revealed that actually it consists of 25% of water. 25% of this is water. It has a crust. See, we will be discussing our Earth has an internal structure. How do we find out that? We will try to just briefly explain that. But then Ceres also has a crust, and rocky crust, dusty, salty deposits of different materials of magnesium, and countless number of craters are present. So that was actually about one class of object which we called asteroid. Next is actually the comets. Comets are actually dirty ice balls. That is what is said. Few days back throughout the world, there was a news that comet Newswise was seen in July 2020. From Calicut also faintly it was seen, though the atmosphere was not clear. So comets are seen from long back, and we know about comets because Halley's comet is very famous because of its periodicity. People predict it, and as the comets move in a very elliptical orbit, means a very eccentric orbit. Sometimes as we will see, that it comes from very far away. Some are short period comets, others are very long period comet. And normally actually the comet goes in a elliptical path, or sometimes it goes in other orbits also, where it will not return, but in periodic comet it goes in an elliptical path, and as it approaches the sun, actually a part of its material get evaporated, and it forms the tail. It forms two types of tail that we will see, that it has a dust tail and an iron tail, and it has a nucleus. So all these things have been found out. Now how actually people know what is inside the nucleus? It is quite interesting to understand how actually people have understood what is inside the nucleus of a comet, and why these comets are important. Because see, for emergence of life, we require water, and in many cases actually, for example in moon, we have seen that in dark area, in polar regions, in shady regions, there are water ice present. Not only in moon, in many other satellites also we will see that there are water present in it. So from where those water came, how actually life came? Many people suggest that actually these comets were they responsible for dumping water in most of these. They crashed, they fell, and they deposited water in form of various forms in these planets. So these are important objects of study, and these become spectacular as they come near the sun. As you can see that it comes in a great range of masses, say 10 to the 12 to 10 to the 16 kg, and its density also varies, but they come in a class. But anyway, it is not like a rocky thing. It is always mostly made up of water, ice, and dust particles. So we have two interesting cases. One is the planet mission Stardust in 2004. It approached the comet While 2 at around a distance of 150 kilometers away from the comet. It gathered some of the materials from that particular comet and analyzed it, and people actually brought back those materials samples back to Earth in 2006, and our scientists could analyze those samples which have been brought back, and ultimately find out what are the materials present. So that was actually it has just gone near, it could not actually touch. But again in 2005, July 4th, a 400 kg projectile, NASA's the Deep Impact mission was there, and it dropped a particular thing in the particular comet called Tempel 1, and as it dropped, actually blasting a lot of gases and ice particles came out. You can see the collision picture is here, and orbiter which sent the projectile, the mother spacecraft, actually it was not an orbiter, it was just flying with mother spacecraft, observed this particular event from a distance of 500 kilometers, and its presence of water, organic material, the thing which dropped there, it did some test, and we understood what are the things which are possible, which are which we theorized and which got confirmed, or some of which got confirmed from this particular thing. So that is about those two how the things. How when we study about comets, generally we study the two-body problem, and we have the central force problem, and these are the equations. These are available in standard text. Just for continuity we kept. Then how, depending on initial condition, its eccentricity varies, and ultimately we define the orbit of this particular thing. So with this brief introduction, we see that there is a class of objects. We have seen that there are asteroid belts between Mars and Jupiter, and there is another class of objects after actually Neptune, post Neptune. As you can see in the figure, they are called Kuiper belt objects. So there are a lot of minute objects have been discovered through the Kuiper belt. Pluto is one of the most prominent Kuiper belt object, which was actually a planet by its initial discovery, but it has been dethroned, and it is now it has been classified as a Plutoid. It has a class of its objects of its own. So why Pluto was actually dethroned, we will come to its history in the last slide if time permits. But one thing is there, that what happened is that when astronomers were discovering in 2005, they discovered a new object called Eris, and its actually size was 10% more than Pluto. And there were a lot of other objects getting discovered which was nearly the size of Pluto or less than size of Pluto, but then people started discovering more objects which are more than size of Pluto, so it became a common thing. So Pluto actually is most prominently a Kuiper belt object, but then ultimately, since it had it has a position in our solar system, so it is classified as Plutoid. There are objects which are mostly bigger than Pluto, and in the same after the Neptune, it is available from the Kuiper belt. They are classified. Now, as we have said that these comets, many of these comets actually they come from this Kuiper belt region. It's called hill region. It is also called a hill region. So another Jan Wood, he theorized that long period comets, how they come. They come from very far away. They have a very eccentric orbit, and it is said that under a very eccentric orbit there are actually a volume of snow ice, sometime like in a very cold depository of circular spherical thing. As you can see, the scale is given here. It's very vast. It's very far away. You can see from this itself how big is this particular spherical thing, that is that our Oort cloud, from where due to some type of instability due to a passing nearby star or some other objects which gets a chunk of this ice piece or some rocky ice piece comes out, and it comes into the inner solar system, and it appears as a long period comet. So Oort cloud is actually responsible for various sources of is the main depository of comet. But then comets are not only from Oort cloud. There are short period comets. There are other comets which are very nearby. It comes. So people have classified various objects through which actually they can observe comet, like scattered disk, the Kuiper belt, and the Oort cloud. They depends on the distance through which actually at which these orbits either recur or they move out, or they have come by the various parameters, mainly based on the orbital parameters. They are classified as various types of comets. Now that was one class. So we have seen what are asteroids, we have seen what are comets. Now let us concentrate, because these are the minute bodies, but these objects are studied very much, because everything studied together only, because we don't know what was actually there. We can't actually get from the Earth what was present to consolidate a model. Our full vision is to consolidate how actually our solar system got evolved, and how everything Earth got evolved, and how actually life came in. All this we want to know, how life, whether, because till today we got only one planet where life exists, and we could not actually forget about intelligent life. Any type of life is not found anywhere else. So whether life is unique. So this is one of the things which haunts astronomers and astrobiologists, and most of the missions to Mars are actually directed towards these astrobiological questions. Now, as these comets move in a path, what happens is that as it goes through the path, it leaves out lot of dust particles through that particular path. And if some of these paths are crossed by Earth, that is there are crossing points, and Earth goes through this particular path, and it draws these particles through its gravity. So as the particles are in the as the particles are in the space, they are called actually meteoroids, and when they come in contact with this Earth's atmosphere and gets heated up, and ultimately it lightens up, and we see something. We will show you that it seems like a streak of light, as it is shown here. We see some streak of light. It is called a meteor, and most of them actually burn off, and few of them, bigger ones, actually they land up on the surface of the Earth. They become very less in size, they are burnt fully, but still they give us an idea about what was the original metal, what were the original elements which were present in that particular meteoroid, which ultimately landed on the Earth, and we get to know about that. So this meteorite, there are a lot of observation, amateur and professional observation camps, observation or international meteorological organization. They are dedicated to the study of this particular thing. So when we speak about this meteor astronomy, we speak about meteor showers. So what are meteor showers? As I said you that meteor come from a particular there are particular areas through which actually this comet has as it passes through the orbit, and when the Earth passes through those junction points, actually it attracts those small particles, and it comes as a streak of light. So there are certain locations behind, for example, it comes in a background of certain constellations. So they have been classified either as Leonid or Orionoid or Perseid because of the background constellation, because they are those particles are present in this space, and it recurs for most of the Leonids. So from where it comes, actually these are actually there are some time of the year when they are when this Earth crosses through those debris, and we see this meteor shower, and that particular point through which it comes, it's called the radiance. So these are some of the meteor showers as you have seen, and it's available. You can go through, and some of these meteors have been actually collected by our various persons, various volunteers who work on, like to study on this, and they have collected, they have experimented, they have sent it to different labs, and they have found out that most of the meteors have meteorite, they are chondritic meteor. They have classified it based on how much iron they have or how much sulfur. Their yellow color is for sulfur, or chondrite or carbonate. Different types of things are available, and this classification helps us in getting what type of elements are actually, from where it might have come, what is its size, what type of temperature it might have gone. All these things can be studied. So this gives an overview of objects which are present. Now let us, before moving forward to our knowing more about our solar system's object, as we have seen that we have to know the terrestrial planetary system, we have to know the jovial planetary system, we have to know about Earth-Moon interaction. That is, these are the two objects, Earth and Moon. Moon is our nearest celestial neighbor, and apart from eclipses and all, which we will not discuss today, Moon is very vital to us, and many things in Earth happens due to Moon, that we have to understand. So before we move on to those particular things, let us just see how actually people think about how our solar system gets originated. This is not a solved puzzle, but people are modeling, and people are trying to refine this model. This is the way actually people pursue science. So if you want to make a model for actually formation of the solar system, what all things you require? So we have to start with certain things, like we require how each planets are relatively isolated in space. They move around in circular orbits. They are mostly lying in the same plane, and they move in the same direction. They revolve in the same direction. They rotate also mostly in the same direction, and planets, these moons of these planets also revolve in the same direction, and our planetary systems are highly differentiated. Asteroids, very old, also exhibits properties which are not characterized by terrestrial or Jovian. They have some peculiar properties, like we have seen that half of the satellite is somewhat different age, appearing as some different age, and northern half and southern half there is differentiation. Then we have Kuiper belt objects which are characterized of different sizes, icy bodies orbiting beyond the thing, and then we have a hypothetical Oort cloud, hypothetical in the sense that it is means logically it has been deduced that most of the long period comets comes from there. So all these things has to be accommodated in a model, and that model actually people want to actually think. So one of the suggestions which has come not fairly, because it has come through observing certain other like Beta Pictoris, and we will see some of the other objects which have been watched, some of the other stellar systems which have been watched, and by looking at all these model requirements, people have come out with an hypothesis which is called a Nebula Hypothesis, where there will be a nebula of gas, and the central part of the nebula will condense to become the star, and the remaining will form a disk. And why should it form a disk? We will just have a brief lookout of all those things. It will form a disk, and ultimately each of these disks will form each of these disks will ultimately fragment through various processes. We will discuss all those, and then ultimately the system gets formed. So that is the full story about. But broadly, actually there are two stories which are actually competing, and one is a catastrophic theory, because everything is rotating, revolving, and there are dust particles, there are minute masses, so there will be collisions and breaking and making. So one is one is a catastrophic type of theory, another is the gradualistic theory. Slowly the things will evolve and ultimately form the full thing, or some of them propose a hybrid model. Now when we say why should a disk form, so we see this particular figure. The first figure shows volume, and you see that there are 2 points A and B, and it is rotating. So it is since it is not a rigid body, so what happens is that the point A, it is easier for the point A to come to point B than point A to means it goes, and so the vertical fall is easier, and therefore what happens is that it flattens and ultimately forms the disk. So that is the way actually disks are formed. But then there was a problem. It is seen that the angular momentum, that is moment of the momentum, so this particular angular momentum as a quantity, the distribution is inconsistent. So what are the things? Why it is inconsistent? So it is said that these planets are formed at the same by the same spinning cloud, and Sun possesses 99.9% of the total mass, but only 1% of the total angular momentum based on its rotational speed and all. And orbital or angular momentum of Jupiter exceeds the angular momentum of the Sun by a factor of around 20. So so these all inconsistencies, how it can be resolved. So one of the proposed explanation for formation of this thing is that the angular momentum is transported from the central part of the nebula to the outer portion. So what are the mechanisms for this particular transport? So again the suggestion is that either it is transported by magnetic field, the charged particles, and magnetic field causes a transfer of angular momentum. So it drags, as the magnetic field moves around the charged particle, it drags the material, and the thing is that it moves out and comes out. So that was one of the suggestion. And the second suggestion is the viscosity, because as we know that viscosity is a dragging force, and actually each layer drags the adjacent layer, and ultimately the slower moves faster and the faster gets slower, and in this way it stabilizes. So viscosity actually is one more mechanism. So a result of these two, actually the materials of the outer solar system gains angular momentum at the expense of the angular momentum of the Sun, and this is the process actually with which angular momentum discrepancy is explained. Now okay, now the angular momentum is explained, Nebula hypothesis there. Now what is the process of planet formation? How is the nebula process formed? So as the nebula gets contracted, it gets hot enough, it moves, the dust particles get evaporated, and ultimately actually these dust particles it gets condensed, it gets liquefied and then solidified. The solid particles are formed from the gaseous matter, and this due to this enormous pressure, this transition occurs matter, and the solid particles stick together and ultimately glows into the comet, glows into the planet, grows into the planet. So depending on the temperature, the gas condensation either from inner region, solid gas condensation into solid happens from the inner region to the temperature high region, where melting point goes on increasing, and there is a sequence of condensation sequence which is shown here, and as the from the inner as to the outer, as the temperature decreases, we see that various types of elements get formed, as it is shown in this particular table, different temperatures and different types of elements. So we see that the element is getting, lot of elements are distributed in that particular process. And then actually the evolution of the planets occur in three particular stages. First is formation of the planetesimals, and then they form planetesimals coalesce to form actually protoplanets, and then ultimately the stable planets forms, and then this actually due to melting as a result of gravitational separation, the planets are ultimately as they are. So that is the full thing. But then there are actually what are the things which accounts for it, accounts for what are the model requirements, but then there are certain things which doesn't fall into this model outright as the model suggests. What are the things? As we know that actually moon is devoid, moon is it's geologically very different from what our earth is, and so if how the moon came to earth, and these are one of the questions which it's not a direct consequence of this particular theory. And further, the Mercury's behavior, as we will see that craters in Mercury, it could not account for being so nearer to the sun, it could not account. Then there are tipping axes, for example, Uranus is fully tipped, Venus rotates retrograde, all these things how it accounts from this gradualistic explanation. It could not directly give the inference could not be directly drawn from all these whatever we have discussed. So then thus the catastrophe event comes inside, and then catastrophic points of view is also taken, and the hybrid model is formed. So it is not just a fanciful theory as we have just thought. There are actually a lot of data which have been taken, and new stellar systems are photographed. You are seeing one of the photographs which have been taken by Spitzer telescope of the star called Fomalhaut at 25 light years from Earth, and it shows the disk forming is taking place not only in Fomalhaut. Actually, we have seen in Beta Pictoris also there are pictures where disk formation is taking place, and people are watching those pictures and analyzing those data to see that different stars, if you get more number of stars, the population gets diverse and the model gets more justified and more reliable. So now one more good thing which we can see is that if you plot the temperature versus the distance from the sun of different types of objects, we can see that it follows a particular curve, and then as you can see that the temperature falls, and we have as we move up from the earth, we have a certain temperature, and then as you move out, the temperature decreases, and different types of water ice, ammonia, methane, and all those things, they try to dominate. So temperature of various parts of the primitive solar system just before the onset of accretion, this curve gives a partial insight of that, and from this actually this also helps in the formation of that. So that was one thing actually we discussed about the formation of the planets. Now, how we said you that there are missions dedicated to actually study other stellar systems, or if to photographs, whether they could photograph not only planets, new evolving planetary systems. So that gives more insight as Fomalhaut, as we have seen. So there are various methods, and Kepler mission was actually fully dedicated for this particular task. So actually it has to observe stars in a particular direction, in certain directions, and you have to record all these things. So one of the method was actually the Doppler method, through which actually as the object moves, as the planet moves about the central star, the radiation it is coming, it moves in that, and there is a shift in the frequency, and this shift is actually calculated, and to find out that there is something orbiting. So that is called the Doppler shift method. Another method which is used is the transit method. Transit method is that if there is a star and there is an object which is just moving in front of it, what happens is that the part of the brightness of the star gets dropped, and amount of time which is dropped, these things are taken into account, and ultimately the size of the object can be calculated. So this is called the transit method. And then there are other methods like micro lensing. So there are these are the standard method used, and Kepler methods. Kepler, as I was telling you, it was launched not 5 years ago. Actually, this is old one. So it was launched few means now 2000. It was launched in 2009. So long time back, and it has given us around 5,300. This is the correct data. It has given in these 9 years of its operation. It has observed and found out a transiting planet of around 530. If you say that 5,30,506 stars, and it was sensitive to the fluctuation of 1 part in 1 million, 1 lakh, you can say, and then it found a host to around 1,790 host stars with a total planetary candidates of 2,660. So many planets it got. It actually it discovered so many planets and planetary systems, and this is one of the pictures in which it shows how it is operating in which direction. And these are some of the results. You can see this graph shows actually how the planetary mass is distributed with respect to the orbital period. Again, we have how the this planet's radius is plotted with respect to C. You can see different side. In fact, people they have discovered super Earths in this process, where the Earth type planets, though Earth type in the sense that not life is not there, water signature is found, but its size is very much bigger. Say more than 2 to 10 super. So if it is more than 3 to 10, it was classified as a super Earth. So there were a lot of super Earth. This was in use for some time. Similarly, a lot of other different classes of stars in planets which are very near to that, very near, and planets which are bigger, planets which are. So different types of planets, exoplanets have been discovered, and this gives a plot of actually different types of planets which are comparable to some of the solar system objects which we know it. So this gives us how many of different types of objects have been known by size. So this was the graph. So these are the various types of plots which have been obtained through this mission. So why all these things, as I was telling you, that one fundamental thing is that people don't understand how they are still trying to understand whether there were life in some other place in our solar system. As far as now it is concerned, we don't know. But then they are also thinking to find out why life evolved, whether it was transported. Fred Hoyle said that life was transported through comets. But then there was one more event called Tunguska event in Russia, where actually everything got erupted, but there is no crater. So people started thinking that from where actually what happened. So now we understand that something has burnt away in the air itself, and the amount of heat it produced actually it cleared off the area which it was. So what are the minimum requirements of life, and what are the things? Based on this, actually people suggested that there will be a zone. There is a zone which is actually a apt distance from the central star, and so that a liquid water will be there, atmosphere will be there, and temperature will be suitable for developing carbon form of life as we know it. So this was called Goldilocks zone, or this was also called as a habitable zone. As you can see, this particular plot shows so our Earth and Mars actually typically fall. So these types of the exact distance of sunlight star, cooler star, their habitable zones vary based on the star's parameters and how far actually the temperature are conductive for those type of things. So additionally, what all we need is that a correct mix of elements, isolation of stars, stability of the star, correct temperature range, all these are atmospheric considerations. UV shield is there, like we have our ozone layer and other things. Complex geological process, that is very important actually, which we will be discussing, because our magnetic field, the origin of magnetic field depends on that particular aspect. So our solar system, before we leave out the first part, our solar system basically, as we are classifying to the solar system, the planets what we see are actually, these are the planets from Mercury to Neptune. These are classified as the objects which have reached its spherical shape. It has got its hydrostatic equilibrium, and it has cleared all its path. There are no third object, and there are no objects passing its path, and this qualifies for being classified as the planets of our solar system, and other things are other members of the solar system. So now we move to the second part of the talk, that we will try to do it fast. We have Earth Moon system, and these are some of the parameters of the Earth. You know, the aphelion, perihelion. These are some radius you can see. Inclination is 23.5. This we have to keep in mind, because when we compare it with Mars, we will see that both are matching, though it doesn't match in the same way with other planets, and its rotational period. So it has 23 hours. You will see that Jupiter, Saturn has a much faster rotational period. So about Earth, the various aspects of the Earth are written there. These are some of the things which we will go. So, most important part of that is that it has supported life. It has a good tectonic plate activity, and which keeps it geologically active, and then it's covered with ocean, and it has a good magnetic field. Its axis is tilted. For that we have the seasons. So all these things are there, and then we have the moon. The moon's parameters are also given here. Though it's a completely different type of world, we will discuss, but then it is our own satellite. It gives us our light, and we get our eclipse phenomena and a lot of other things because of this certain thing. It has an axial tilt. So if you go to moon, what happens is that you see a sky which is pitch dark, fully dark, filled with sky. There is no blue sky and all. It is dark color sky, or you can see these stars. Then it star circle at 27 and 1/3 days, and then from one point there are certain there is no Earth rise, as we can see that moon rise from Earth. There is no moon. If you go, due to its synchronous orbit, why it is synchronous we will try to discuss. Due to its synchronous orbit, there is no moon rise, and there is no moon. There is no Earth rise and Earth set, and we see from each location at a particular height only the moon is seen, and then its gravity is low. This is a common phenomenon. But one more thing is that due to absence of its atmosphere, its temperature changes from around 100 degrees centigrade to minus 50 degrees centigrade. So it's a huge variation in temperature, and that gives us the importance of the temperature. And it is exposed to ultraviolet light. It is internal silence. These are things always present. Now let us see how actually what are tides. Now we are all familiar. Being, for example, if I am from Calicut, I am staying in Calicut for quite a long time. So anybody staying in a coastal area or any water body like river or something which are present nearby will understand how actually this water level rises to a higher level compared to the normal thing, or sometimes it goes down. So you see that a large portion of the shore is either seen, or sometimes they get submerged in the water. So what happens actually? This phenomena is called tide. So why it happens? You can see that moon and earth is there, and there are gravitational force. If you do the differential form of that, you get it here. So that was actually the direct equation. Now if you take the component, if you take moon here and if you take a point on the moon, because we want to find out the difference in the force between the point P and the point C, that gives rise to the tidal force. So we can calculate the component as it is shown here. We can take the different components in the x and y direction. So here you can see that theta, phi both are defined as from the figure, and ultimately you can find that the differential force actually is given by this particular thing. So there is a differential force between the center and the edge, and it is directly proportional to sine of phi, and also inversely proportional to the cube of the distance between the object and the earth. So this is not only important for the earth moon system, it is also important. Actually this phenomena is indirectly responsible for something called a Roche limit, which is responsible for ring systems in our planetary system, that we will come to see. So we will see that what causes this side. So this is created by an imbalance in force. So you have seen that there is an imbalance in force. So as the mass increases, the gravitational force increases. If the distance increases, the gravitational force decreases. And centripetal force is required for bodies too. So there are gravitational force, centripetal force, and you can see that the gravitational force is directed towards the means as we know that between the centers of the body, and centripetal force is parallel to that. So we have a resultant force which is acting, which is working as a resultant of these two forces, and ultimately there is a drag. So what happens is that if you consider our hydrosphere to be uniformly filled around our Earth, with a hydrosphere is there, and when the moon comes overhead at a particular location, so there is an attraction, and since the moon water is having a lower mass compared to the Earth as such, the water is getting attracted. So actually what happens is that there is a bulge in the moon facing direction. In the other case, actually where there is no moon, the Earth, since it has moved, it is getting attracted, it moves away from the water. So we always have a two bulge, and this bulge actually is rotating. This bulge is dragging, and that actually expends our own energy, as we will see. So that these are responsible for many types of things, as that the Earth-Moon distance is increasing at a rate of 5 centimeter, I think, 4 centimeter per year, and so these things are happening, and then these drags become more important because this, as I have said you, that this is a force. So if the moon is apart from moon, if sun is also there, so sun is a very massive body, it is far away, but still it has a force component. So we have the moon and the Earth. Moon is there, Earth is there in the same direction, or moon is there and Earth is there in opposite direction, or they are in perpendicular to each other in the configuration. So these gives rise to different types of effects called spring tide and neap tide, and their level at which the water rises changes. And as I was telling, as this drags, what happens is that it dissipates, energy dissipates, and it also causes heating. So as I was telling, that due to this energy dissipation, the energy loses and the distance between Earth and Moon increases, we have seen. So this is there. So this is what I was saying, that saying about Earth from Moon, as you can see. And I was saying about one more thing called Rossi limit. The Rossi limit is actually if the distance of a planet from or a satellite from a planet, or a planet from a star, it becomes it decreases beyond a certain level. What happens is that due to tidal difference in forces, it ruptures, it fractures, and it ultimately forms either a ring system or it falls back on the particular planet. So these calculations shows the how for Earth-Moon system, how actually the Rossi limit is there. You can see that if the force on Moon is less than force on the tidal force, then if this condition is satisfied, we will have this particular expression. And if an object actually comes inside this Rossi limit, what happens is that it actually fractures. But then you can say that can't any object move? It depends on the size of the object also. If this object is very small, like in our spacecraft, if it goes, it will not fracture, because it depends. The difference in temperature means that force may not be appreciable to break it, but it depends on the size of the objects, and this is responsible for many of the things. We have seen that our Shoemaker-Levy comet has crashed, and ultimately it fell on Jupiter due to this particular effect only. And then we have next we move on to actually discuss something about our atmosphere. So our atmosphere, from where does it come? Atmosphere, how did we Earth get an atmosphere? So atmosphere is very important. So what happened is that we have eruptions of the volcanic eruptions, and the entrapped gases are left out, and they are left out from all the chemicals and all which were there. They formed the gases and all which they formed actually are exposed outside, and ultimately they form an envelope surrounding. Due to gravity they form, and it is retained because of the temperature, because of the mass of the Earth, so that the velocity with which actually gas can escape, and the gravity with the force with which means the force with this velocity with which escape velocity is less than the average velocity, then actually it is retained. So in this way actually we have an atmosphere, and based on the density of the atmosphere and the constituent of the atmosphere, actually there are various layers, as you can see, from troposphere to exosphere. So we have an atmosphere very thing, and there is a temperature gradient in the atmosphere. But if there is no atmosphere, these shielding effects, this also shields from ultraviolet light and other things, and also things that it keeps the temperature coherent throughout the globe because of an effect called the greenhouse effect, because there are certain type of molecules like carbon dioxide and other molecules which actually traps heat, and due to this heat which is actually heating the land and ultimately it gets trapped inside the atmosphere, this phenomena is called greenhouse effect. And this is actually not only it is giving a good service to earth by maintaining the light, but it is sometimes dangerous, as you will see that Venus, though it is very look to see through a telescope or watch in the sky, it is actually this greenhouse effect doesn't permit us first of all to see what is inside, and it is very hot and inhospitable in that particular thing. So some of the though we don't have any gaseous thing, because of, as I said you, that there are certain parameters like escape velocity and the root velocity of the gas, average velocity of the gas, so that if average velocity is less than the escape velocity is retained. So most of these parameters are not satisfied, may have not been satisfied in the moon. So moon has a very tenuous atmosphere. For the moon, whether it had a very strong atmosphere is also questionable because of its geological features that we will see. And ultimately, actually, we do through the analysis of various instruments which have visited there, we have these are the gases as is shown here: argon, hydrogen, neon. Some with very less portions are available in the thing. Now, as we were speaking, how do we know so we studied about atmosphere, we studied about other objects. Now, how do we know inside, what is inside the earth? Now, the answer comes from the seismological study, that is the geologists. They study the thing. They study the thing by using two types of waves, mainly. They are called the pressure waves and the shear waves. And these waves actually, when for example during a earthquake or artificially if they create certain types of waves of this spot, so they travel and they get reflected from either they penetrate or they reflected based on the density of the material. So based on the delay of if you send a wave, if you are transmitting the wave and you are seeing the reflection of those waves, so based on this reflection actually and the time difference between the outgoing and incoming waves, from where it is reflected gives us an idea about what type of material, what is the density of the materials which are underneath, and that gives us actually the approximate idea about what type of features are there underneath. So this is the way actually people study the cross section of various Earth. So our Earth, if you cross-sect it, it has a mantle, it has an outer core, it has a crust, and these are things. As you go central towards the Earth, actually people might not have gone beyond say 10 kilometers. They might have done, but we know that our radius of our Earth is around 6,400 kilometers. So if you go at the center, it gets heated up high, and it becomes a molten means iron molten things, and metallic, and the thing is that as Earth rotates, that particular spherical molten metallic thing also rotates, and this gives rise to charged particles are there, and those gives rise to fields, and these are the origin of our magnetic field. So if there is no such a hot core at the center, there is no magnetic field, or it is very less, then magnetic field is not there. If magnetic field is not there, if those classifications of the geological things are not there, we don't have actually the continental drift, as we don't have any continent change, or as Werner has proved, the plate tectonic movement. All these things are actually relative to the geological features. So they, if we can understand what is the whether we can measure the field, or whether we can measure the we can do experiments with those waves, we can get the internal structure, we know the geological features of that. So these are some of the recorded quakes which have been found out, though very negligible. Moon is actually geologically practically dead, but very feeble quakes are recorded, and it has a very inactive geology, so there is no much geological features, so that is do not travel so the liquid through the liquid, and this is the structure which is ultimately found out through the cross section of the moon. You can see the structure of the moon, and we can contrast it with the structure of the earth. So based on all these things, as we were moving that, we have a mosaic of all these. This is a plate tectonic jigsaw. All these continents or the things whatever you are seeing on the surface features are a part of certain plates, and these plates are actually moving, and it has been argued by scientists that due to this movement, it was once in a time all these landforms were all together in form of a thing called a Pangaea, and it was a supercontinent, and then actually it got split. So that is one thing actually which is very important. And then we have the composition of different materials which are present, and not only that, when we study the moon, actually we see that there are classically different views, means different surface features. If you see the far side, which is not visible from the earth, which has been studied by space probes, and the near side, so there are dark areas like Maria and all which are available in the near side and which are not available in the far side. So these are some of the features. You can see dark side, rallies, craters, different types of impact signatures, these are seen, and surface of the moon has been studied by different missions like Luna missions of Russia, and we have the Apollo missions of America, and we have Indian missions also, Chinese missions also. Many of these missions have been used to study, and people have found out they have found out mineralogical mapping on the surface of the moon. We today know what type of mineralogically it is distributed together. In fact, Chandrayaan-1 has found out the signatures of the water which has been available in the polar shady regions of the moon. So south polar regions have been covered by many, not only our Chandrayaan, there are other NASA's instruments also which have been used to study all those things. So people then argue that what are the sources of water on the moon? So how water? It might have existed, or it might have been primordial, or it might have been dropped by the cometary impact there. Water movement to the subterranean level depends on porosity and pressure gradient. So all these there were different types of things which were involved, and people argue, and though the debate is not yet settled. And then we come about the Earth. As I told you that the geologically Earth is very active. It has a central core which has a high temperature, and it has a good magnetosphere, and this magnetosphere actually saves us from the solar wind. Not only that, because a lot of charged particles are trapped by those magnetic field, and they go to the central polar region, and we see beautiful auroras when we go to the North Pole or the South Pole. These are the polar aurora australis and polar borealis, so northern and southern sky. So these are some of the things. I will move a bit faster because actually the time is not there to explain much. Now, as I was telling that when we saw the density, we saw that there are two classifications. One is a terrestrial classification, that is we have two groups. One is Mercury, Venus, Earth and Mars, that is one group of planet, and then we have the Jovian that we will discuss. So first thing people started thinking is about Mercury's curious spin. So Mercury has a curious spin. People, Percival and all people previously thought that Mercury was static. Then they used RSC radio telescope, and they have radar studies they have done, and they found out that actually Mercury is moving, and ultimately they have seen that the Mercury's rotation period was initially fixed to be 88, and then it was precisely brought down to 59 days, and actually all this peculiar motion is due to the combined effect of Sun's gravity and Mercury's very eccentric orbit, which complicated the motion. So this is one thing. So next thing is that we will just restrict and we'll go faster. So next thing is that we have the planet Venus. Planet Venus, as I was saying you, that it is good to see. It is very bright object in the sky. But why it is very bright? Because it is opaque, so we can't see what is inside directly. So, but there are certain other things that it rotates retrograde. Now, why it rotates retrograde is not yet confirmed. Nobody knows about it. But its inclination angle is 24 degrees. We see that the inclination angle of our Venus, the inclination angle of Earth, the inclination angle of Mars, these are all around the same time, and it rotates retrograde. Its periods are also matching. So this is one of the things which has to be taken care of. So we have Mars also that we will be discussing. So these are the few planets which we have seen. Then the atmosphere. When we see about the atmosphere, people have actually studied the atmosphere, and some probes has already been put to actually transmit, and even there were Russian probes which ultimately settled down and transmitted for around 50 minutes, and we got certain information about what are the surface features and what are the atmospheric features of the Venus. And people have there are actually certain European observation where Venus Express in 2006 showed that there were actually there were vortex in the polar region of this particular planet. So this has also been recorded. So this is about the atmospheric features of this thing. The Mercury is devoid of atmosphere, but Venus is having a total very thick atmosphere. In its atmosphere is though there are the liquid water is not there, but sulfur. Its surface is dominated by sulfur, and we have the sulfur hydrochloric acid droplets dominating its atmosphere. This is a picture. Now we will discuss something about the surface features of the various planets. Like we have Mercury. You can see that its surface is not as cratered as our Moon, neither as cratered as many of our other asteroids or something, though it is near to Earth, near to Sun. But then we have certain types of craters, like one crater within another. There are certain things which have been found out by various messenger mission which has actually photographed this particular planet, and based on various studies, actually its interior has been studied, and it has been found out that it has an unusual interior. There is a solid inner iron core for about a thing quite 2030 kilometers, and around 410 kilometers of crust and rocky mantle of the salt. So this type of actually Mercury thing has been categorically found out. Similarly, people have actually studied by various probes. They have studied the topography of Venus, and they have studied that there are two main surface features which actually can be made equivalent to something like a continent on the surface of Earth. They are actually Ishar Terra and Aphrodite Terra. So these are the landscapes, and they have some mountains on the surface of the Earth, which is around 14 kilometers from the deepest level. Which is shorter than our Mount Everest, which is having 20 kilometers from the deepest ocean floor. And and there is actually Magellan, after the observation, has ruled out any type of geological activity. So it is somewhat like geological dead planet. So there are a lot of there are some volcanoes, though it is geologically inactive, it is said in one place, but still around some 36 volcanoes have been traced out, which are not very old. And it has also been found out that amount of sulfur dioxide in the atmosphere of Venus actually it changes abruptly and frequently, fluctuates. So that is one thing. So this is a comparison between the surface features of Mars and Earth. So next we will come to the topography of Mars. You can see the topography as it is found out from various orbiter and lander missions. So there are a lot of rolling volcanic plains in the northern hemisphere, and there are in the southern hemisphere it is heavily cratered, lying with ups and There is a contrast between these two, and there is a bulge called the Tarsis bulge, which is one of the major geological features in this particular planet. Apart from this, actually there are certain craters which has also been found out due to about a lot of meteorites impact on this particular thing. You can see a few of the craters which are highly marked and which have been recorded by various missions. And there are various types of channels, like runoff channels, outflow channels. Runoff channels are mostly found in the southern highland, and the outflow channels, which are mostly like watermarks, like something has water has flown some due to heavy flooding or something. It has been found out in the equatorial region. So it has been people are trying to send so many things in the hope that they will find out some trace of water, and people have theorized that it is present in a permafrost layer, a layer just below the planet's surface, and people are trying to find out that. So this is all about we can say about these things. And it has two irregular shaped moon, one is called Phobos and Deimos. And so we will end up we will end this section showing some of the features of Mercury, as you can see. We will not again go into all the details. Actually, it has a Mercury's tail to Mercury's, we have seen rotational axis, its surface features. They are quite contrast. It has the period of its rotation. So we will just explore the Jovian part so that we logically conclude. We have explored the terrestrial planets. We are exploring the Jovian planet. Jovians are, as we have seen, that the Jovians are mostly gas planets, gas giants. So there are a lot of probes which have visited Jupiter, as it is illustrated here, at various phases of time, and they have given us a lot of information regarding the same. Similarly, we have Pioneer, Voyager 2, Voyager 1, Cassini, Huygens. So they have also given us. So basically, these are the two prominent gas giants, and we have the Uranus, which is though Jupiter has actually a very differential surface layered atmosphere, which we don't find it in either Saturn or Uranus or Neptune. But then there are certain elements which are present in Jupiter, like there are certain compounds, the ammonia type of compound, which are found in Jupiter, which are not found again in Uranus or Neptune, which are mostly with methane, majorly with propane and then methane and all those things. So discovery of Jupiter was there by William Herschel, and we had Neptune discovery theoretically by our Adams and Leverrier. Afterwards, Galilei has actually observed it. So these are some of the features. Now we will not go into much details, and there are some surface features like our Great Red Spot, and they have found out certain electrical activities, certain cyclonic activities also on the Saturn's atmosphere. People have gone through the interior of the Jovian planets. They have seen the magnetosphere of these things. You can see the aurora is present also in the polar region of the Jupiter, not only on the Jupiter, on the Saturn. So it is a phenomena showing that magnetic field is there. So basically, if we don't have now time, so I will just then we have the ring system. The ring systems are spectacular. We have other moons in our planetary system, like Jupiter's Io, Europa, Ganymede, Calicut. So it has nearly 80 moons, but these are the 4 Galilean moons, and Io is the most geologically active moon. It is actually not due to its internal thing that it is geologically active. This is, people have cracked out that its energy comes from the tidal, means its interaction with the Jupiter. So all the tectonic activities which is happening on this particular thing is due to the Jupiter's gravity. So that is quite interesting. Europa has a lot of water. It is a watery world. A lot of watery breezes are there. Then we have Ganymede. So like that, we have other satellites. Huygens have been actually the Titan, imaged the Titan, which is the moon of Saturn. To a fair detail, it has gone down. And then we have the various ring systems. There are gaps in the ring systems like Cassini divisions, which are due to these various moons which are present, and these things can be discussed. And then we have discovery of our other objects. Now, why Pluto was actually ultimately demoted? So we have a timeline. With this, I will actually put the last slide. That is that the Quora was actually discovered in 2002, which is half the size of Pluto. Then Haumea was discovered in 2003, which is again less than Pluto, around 1,500 to 2,000 kilometers. Then Makemake was discovered in 2005, but Iris, as I said you already before, in 2005 it was discovered, and which is around 10% more than the thing of Pluto. So it became common that there are a lot of objects and Pluto cannot be considered anymore as a planet. So it was demoted as a dwarf planet, but ultimately many people were not happy, and IAU in 2008 decided to call a class of objects Plutoids for any type of planets which are any type of cuboidal object beyond Neptune, which are above the mass of equal to or greater than the radius of Pluto. So with this, I think I will conclude my talk. Thank you. Yeah.
So thank you for this interesting talk, and I will go to chat to see the questions. So the first question is by Nebula Siranjeevi. He asked why the planets beyond asteroid belt are gaseous in nature, and he thinks that it should be opposite way around.
No, as we have shown you one curve, I'll just show you that curve, that during the primordial time, actually what happens is that the type of temperature is changing. I'll just see whether that slide I can find it out. So what happens is that the temperature changes from the near to the sun, the type of material and the type of geological activity which it can support to its most. So whatever was required for a silicate type of rock formation core is no more actually available when you go to those far away region. So that is the reason actually the value it could not actually form the central solid core in most of the cases, and ultimately it remained, though it has a huge thing about it has a gravity, it has a material, but it has some type of element like hydrogen and helium are mostly dominating in those Jovian planets, and that is the reason I just wanted to show you that curve, but not getting where it is. So that is the reason. But I would like to understand why actually the person who has asked thinks the opposite way around. What is the logic? Can he explain?
Yeah, can you go to play Nebula and explain your logic? You can unmute yourself and ask. Okay, so the next question is by Sabna Banu, and the question is Earth-like planets are present in our universe not by theoretical prediction but by observational evidence?
No, up till now nothing is Earth-like in the sense life is not present, but there are, as I have said you, that there are super Earths, Earths in the sense that in the habitable zone, but bigger the size. For 3 times the Earth size, up till 10 times the Earth size, Earth-like planets, but life, there is no signature of life as far as now we have. There is nothing has been present. Nothing has been detected so far.
Okay. Extending the questions, he further says that is it possible to see the signature of life on Venus in future, to shift there or something like that?
First of all, Venus is incompatible to the form of life which we know today, because what has happened is that we require water. Venus doesn't have water. We require a temperature. Venus is the hottest planet, so life cannot survive there. So I don't think there is much logic in finding out the life as is known to us to be in Venus. Maybe there may be other form of life that is unknown to us, that is there always. But the life which we know, there is no possibility of finding anything on Venus.
The next question is by Aditya. And the question goes like, how come Venus atmosphere is still not been stripped off by solar wind, even though it does not have magnetosphere?
So Venus atmosphere, actually what happens is that it is very dense, and as it has trapped greenhouse, and it is as we are saying that it's like our Earth's twin. It's geologically its mass is there, so it has the capacity to actually retain the atmosphere, like our Earth has also retained the atmosphere, but the size of Earth and size of Venus is somewhat matching if you go through the parameters of the size. But if you see that Mars is much smaller in size than Earth. So because of this, as I said, the retaining atmosphere, the main parameter is that the velocity, not the only the solar wind. Solar wind is also there, but not only that, because the RMS, that is the mean velocity, the mean gas velocity should be less than much less than the escape velocity of the planet or the satellite. And our this Venus and Earth are nearly similar mass, so it has retained. I think I have answered.
So I request other audience, if they have some questions, they can unmute themselves and ask themselves here. So actually, I have one question out of my curiosity.
Yeah, please.
Yeah, you explained that there are two theory of solar system formation, one catastrophic and one gradualistic. So my question is which theory favors more in satisfying the observational constraint?
Which one? Which theory?
Which theory is more suitable in terms of satisfying or meeting the criteria which we get from the observations in our solar system?
So one thing is that, see, we are yet observing. We are yet observing many other stellar systems, and we are, for example, I have shown you like Fomalhaut stellar disk. Similarly, Beta Pectoris stellar disks are there. So we are just observing more and more disks, and we are seeing how the planets form there also. In our model of this gradualistic growth, actually many things are compatible, but as I have said you that this Venus, why it should rotate retrograde, or why the Uranus should actually have tipped off, or why Earth should actually have a moon as we have, these answers are not very apparent from our model. So people are actually thinking that it is a hybrid model where gradualistic as well as catastrophic model are both acting together to form, but I think the last answer is yet to be obtained by more observations.
Okay, thank you. And the comets you described, that do we have some information about the type of organic molecules if some comets have?
Yeah, I said you that there are some missions which has actually, like Temple in that Temple 1 comet we had the BACT probe, then we have Stardust mission. So people have actually got the materials and samples from the comet, and they found out that there are organic materials present. But that organic materials, though they are present, but that from those inference you can't directly infer that they are the harbinger, they are the actually messengers of life, or they are the bearers to deposit life. Those theories are not established, but it is true that many organic molecules have been found out in the material of those comets.
Okay, so I think these informations of analyzing organic material comes from mass spectrometer or like this, right?
Yes.
Okay, so what are the other techniques if you can mention which are being used?
Yeah, so one thing is that by observing the normal signatures of the radiations coming from that particular comet, like we normally see any object like stars or any particular object's light, and we try to infer what are the spectral signatures of that particular object. Similarly, if you have the material from that, and then you do the spectroscopic mass spectral, as you have just now said, that mass spectroscopic studies, these are some of the techniques actually which they use, and this is what is known to me. I don't know whether there is any other.
I take the last question from Krishna Prasad, and he asks, Uranus and Neptune appears plain and featureless. Is it because we don't have enough clear pictures in images are like Venus?
No. Actually, Voyager 2 has actually visited Uranus visited means by flyby. They have taken a lot of pictures, and we had other like New Horizon during its flyby also has taken a lot of pictures of these, and some of the probes has actually diverted, like Pioneers. So some of the probes have actually diverted their path by taking the gravity assist without photographing Saturn, and went to actually photograph Uranus and Neptune. So we have a lot of photographs now. We have though more direct photographs are wanted, but whatever conclusions we have enough photographs, and it is a gas chance, and there is some mechanism because it is in a remote location where the temperature is low and the geological activity is not there. So this question means the features as we see as far as the present images which are obtained is fine, because gaseous we will not see any surface features as such. And one more thing is that all these four planets, this Jovian planet, that is this Jupiter, Saturn, Uranus, Neptune, amount of radiations which they are receiving from the sun, and amount of radiation which is coming out from the particular gas, these planets are more. It is giving out more. So it is not always that it is actually, it has an energy mechanism. It is not the energy mechanism. There is something called a helium fall. Helium actually cannot stay in that. It crystallizes and it uses the heat, and it condenses in the center, compresses and gives out heat, and that is a energy mechanism. People suggest that is giving more energy. For example, Jupiter gives twice the amount of energy in infrared than it gets from the sunlight. So these are some of the things which have been found out.
Yeah. Thank you so much. I thank the speaker for giving a wonderful talk and this giving a lot of information to us. Thank you so much.